Hello, this is Mr. Jewell. Welcome to the first Math Notes video 1.1.1 on functions. Since this is the first video, I'm going to go ahead and give you some instructions on it that we can skip afterwards for the next videos. But what are you supposed to be doing while you're watching these videos? You should be taking notes. You don't need to write down every word that's on the slide, but you do need to write a summary so that you can go back and look at those notes for quizzes and tests. I do also want you to write down all the figures, so any graphs especially need to be written down, need to be drawn or sketched. They don't have to be drawn perfectly, but they should be well sketched, and you have a nice graphing notebook to help you with that. I want you to write down and sketch the extra examples that I give you, as well as the practice problems. Some little extra notes here on the side. I'm going to do my best to keep these videos under 10 minutes because I value your time and don't want you to spend hours and hours on this. The Math Notes videos are going to be worth 10 points, which is the same as a classwork or homework. So it's a pretty easy way to pick up some points in the class. Watch the video, answer the questions, and get yourself ready for the quiz or test. And you should be prepared to share your responses to the practice problems in particular with the class the next day when I come around and check. So let's get started. 1.1.1 functions. This is the Math Notes page from your book. You should have a square similar to it in this section. We're going way back to functions, which we actually covered on day 1 of integrated 1, and now it is day 1-ish of integrated 3. So these don't go away. We're seeing it again. Little review. So a relationship between inputs and outputs is a function. You should write that down. If there is no more than one output for each input, then it is a function. Okay, so you can only have one output for each of the inputs. Functions are often written as y equals something, some expression involving x, where x is the input and y is the output. So that is key to knowing the difference here. X is the input, y is the output. The following equation, table, and graph represent the same function. So here's the equation. Y equals x minus 2 squared, which you should recognize from last year as a parabola that's been shifted 2 to the right from the origin, which we have right here. Parabola shifted 2 to the right, so we have our vertex at 2, 0. And then here's a bunch of points on that parabola. All of these represent the same function. So how do we test if it's a function? Well, the easiest way to test is if we have the graph is to do the vertical line test. Remember that? So we have some vertical lines here. If we put them through our function, they should only cross one time. That means, for instance, that if my input is 4, so I'm going to have a vertical line on the 4, the output is looking like 4 right there if we follow that over to the left. We have one output for one input. And sure enough, here it is on the table, 4, 4. Same here. Now we have an input of 2, an output of 0. There's our 2, 0. If we have an input of 0, our output is also 4. Passes the vertical line test. Does not cross the graph more than once with each vertical line. So some more definitions to remember. The set of possible input values for a function is called the domain. This set contains every x value for which the function is defined. So again, we want to remember domain goes with x. The domain of the function above is all real numbers. We can plug in any x value into this equation and we will get an output. Okay, there's nothing that's going to give us imaginary numbers. We can plug in any x value and we will get a y value, any real x value. Alright, the range of the function is a set of possible output values. This set contains every y value that the function can generate. So if we look at this graph, our y's, the lowest y value we have here is 0. That's the bottom of the parabola, that's vertex. The highest y value, this thing keeps going up and up to infinity, so it's going to go from 0 to positive infinity for the range. So the range is the y values. Alright, let's talk about function notation and function machines. Again, we did this way back at the beginning of Integrated 1 as well, and here it is popping up again. Except now you guys have a lot more knowledge. So we have the input is the x, the output is the y is 9. So if we plug an input of 5 in for x, we're going to get 5 minus 2, which is 3. Square 3, we get 9. But instead of just writing y equals, we're going to write f of x equals. In this example, f of 5 equals 9. The input is 5 and the output is 9. And we read it as f of 5 equals 9. The reason that we like this notation is it gives us more information. This tells us, when we look at this, the input and the output. If we just wrote y equals 9, all we would have is the output. We wouldn't know what input gave us that. So this gives us 2 bits of information. The other thing this does is we're calling this function f. But maybe we have multiple functions. Maybe there's a g of x and an h of x or whatever. Now we have a way to name those on our graph and on our paper if we need to. So f of x, g of x, h of x can all be used. Finally, this last bit here, they give you something that is not a function. This is a circle equation. X squared plus y squared equals equals 1. And it's not a function because there are 2 y values for the same x value. So if we draw a vertical line here, we'll get 2 places that it crosses. So it fails the vertical line test. Our input, in this case, I'm going to pretend that it is 0. Having a little trouble getting it right on the 0 here. But that gives us an output of positive 1 and negative 1. So it fails the vertical line test. So this might be a good place to pause the video and go back and look at anything that you need to write down. As a side note, you probably should be pausing these pretty frequently so that you can sketch the figures and write stuff down as you go. If you just try to get it all in one shot, you're probably not going to get everything. Alright, let's move on to additional examples. I have 3 additional examples here. We have 4 figures in this first one here with the domain and range listed for the figure. And we want to try to figure out, is it a function? Well, the way we're going to check that is we're going to look at the inputs and see if they have more than one output. So because this 3 has an output of 5 and an output of 6, this means it's not a function. If you were to graph this out and we had something like this, we could come over here to 1, 2, 3, 1, 2, 3, 4, 5, 6. Our input, our x is 3, and it crosses at both 5 and 6. So that would fail the vertical line test. It would go through both of those points. So this is going to be no, not a function. Nope, not a function. We look at this next figure. This is going to be a function because each input only has one output, which is the same scenario down here. So both of these are yes. And then we have the same scenario in figure 4 as we had in figure 1, which is we have an input of -6 with 2 outputs, so that would fail the vertical line test if we graphed it, and would be nope, not a function. We go over here, I already wrote this down, we have no here, not a function. We have a sideways parabola shifted 4 to the left, and if we did the vertical line test through here, we would see that sure enough, if we had, say, an input of -3, it's going to cross both at +1 and -3. It crosses 2 places, so it fails the vertical line test and is not a function. Conversely, this guy down here, which would be something like y equals x squared, and that family of functions, sorry, y equals x cubed, we'll pass the vertical line test. Everywhere we draw a vertical line, it crosses our graph only once. Right here, right here. So that is a function. So to leave things off with you guys, I'm going to give you these two problems to look at. Look at those graphs of two disjoint functions. Answer the or discontinuous functions. Answer the questions 1 and 2 there, and be prepared to talk about it in class tomorrow.